Hey folks, why did that one coffee cost you twice? Most payment systems look like this. You click pay, money moves once. The user sends a payment request to the API. The API forwards the charge to the bank. The bank authorizes the payment and returns success. This simple flow works every time. That works until the network glitches. Watch what happens when the bank takes too long. The payment API sends a charge request and waits. The bank is slow, the timer expires, and the request times out. The payment API, not knowing if the bank got the first request, decides to retry. It clears the timeout badge and sends a second charge request, hoping this one goes through. The bank receives the second request and processes it. But it also already processed the first request from the earlier attempt. Now the bank has two charges for the same payment. That's the double charge caused by a simple retry without protection. The fix is an idempotencykey, a unique token that identifies each request. The client sends this key with every payment request. If the same request arrives again, the API sees the same key and knows it's a duplicate. It immediately responds without charging the bank. With this, the system can detect duplicates before they reach the bank. We need a place to store these keys, an idempotency store. The payment API will check it before sending charges to the bank. A request arrives from the user. The API checks the idempotency store for that key. Since it's missing, it charges the bank. The bank processes and returns success to the API, which then responds to the user. Now, a duplicate request arrives with the same idempotency key. The API checks the store again. This time, the key exists, so it skips the bank and immediately returns the previous response. Now, even if the client retries, the service can see the duplicate. Let's walk through it again, this time with the store in place. The user sends a pay request. The payment API checks the idempotency store and finds no record. It forwards the charge to the bank network. But the bank takes too long and the request times out. The client sees the timeout and retrieves automatically. A second pay request arrives. The API checks the store again. This time, the store finds the previous attempt's record and returns the cached response. The API responds to the user with success, no duplicate charge. The idempotency store prevents duplicate charges from ever reaching the bank. The retry is handled without hitting the bank again. Where does the key come from? The client generates it, often with UUID v4. For this payment request, the client creates a unique key and attaches it to the outgoing request. A robust idempotency key combines the current timestamp, the user's ID, and a random nonce to guarantee uniqueness. When the payment request arrives, the payment API checks the idempotency store for the key. Using a high quality source of randomness like UUID v4 ensures practically zero chance of collision. The server then processes the charge. A good key generation strategy prevents even the rare chance of collision. Let's put the two paths side by side. Without idempotency, a duplicate payment request leads to two separate charges to the bank. With idempotency, the payment service checks the store first. The first request goes through, but the second finds the result and skips the charge. Without idempotency, the bank gets two charges. With it, only one. The idempotency key makes all the difference. So, without idempotency, you risk double charges. With it, you guarantee exactly one payment. Idempotency is the simple fix and it's widely used. But is this enough? Not always. The bank might not support idempotency. What if the idempotency store itself crashes? Without it, duplicate charges could slip through. Bank networks have their own idempotency keys. A payment could be accepted at the bank, but confirmation lost. If a payment fails after the bank accepts it, the system issues a compensating transaction or reversal. This ensures funds are eventually consistent. Webhooks notify the merchant or user of final status, even if the response was lost. These are advanced topics for another video. So, double charges happen when retries without idempotency hit the bank twice. The fix? An idempotency key and a store. But always consider bank level support. That's the breakdown. Subscribe to this channel for best practices for system design. Catch you in the next one.